Hey there, and welcome to the Sudo Show, brought to you by the Destination Linux Network. Today, we take you into low orbit with Tyler Browder of the Kubos Corporation, and how they utilize open source and cloud native to provide a smarter satellite management suite. All that and more on this episode of the Sudo Show. Welcome to the Sudo Show, your home for all things enterprise open source. I'm Eric, the IT guy, and joining me every episode is my Star Trek loving co-host, Brandon Johnson. How you doing today, buddy?
Doing great, Eric. Just, as always, I'm looking forward to this conversation. Space has always been a big thing of mine. My dad works in the aerospace field, and so it's always been a huge interest of mine. My dad's built satellites, he's built rockets. So I'm really interested in this particular side of the satellite industry.
And no matter how many meetings I have racked up in a day, I always look forward to these conversations. And I've been particularly excited about this one just because space and technology was one of the things that got me into IT in the first place. So today we get to kind of indulge that inner child of mine. But I have to ask, Brandon, before we get started, what is the best Star Trek?
That's a tough one. But for me, it's...
Is it, though?
Oh, I like almost all Star Trek. Almost all. Basically, all Star Trek except for the 3 movies by Abrams. So, yeah, I'm in the Abrams verse. Otherwise, pretty much like all Star Trek, more or less.
Well, now that we've probably sparked a nerd war, let's hear about our friends and sponsors, DigitalOcean and Bitwarden, before we meet today's guest. This episode of the Sudo Show is brought to you by DigitalOcean. Now's the perfect time to dive into DigitalOcean because their new app platform service helps you build modern, cloud-native apps for way less money. With App Platform, you can build, deploy, and scale apps and static websites faster and easier than ever using a simple, intuitive interface. Simply point App Platform to your GitHub or GitLab repository and let it do all the heavy lifting, whether you're using Node.js, Python, Go, or even container images. By running App Platform on their own infrastructure, DigitalOcean keeps your costs significantly lower than other products. Plus, it's built on DigitalOcean Kubernetes, providing a smoother migration path so you can take more control of your infrastructure setup as well. As a Sudo Show listener and a member of the DLN community, you can get started building your world-changing app with their App Platform for free. And it gets better. DigitalOcean will give you a $100 credit when you sign up at do.co/DLN. Again, go to do.co/DLN to get started with your $100 free credit on DigitalOcean's new app platform. We want to thank DigitalOcean for sponsoring this episode of the Sudo Show and the entire Destination Linux Network.
Today's episode of the Sudo Show is brought to you by none other than Bitwarden. Bitwarden is the easiest and safest way for individuals, teams, and businesses to store, share, and sync sensitive data. You can go to bitwarden.com/DLN to check out their amazing service. You may or may not know that websites and apps are under attack every day, and because of this, security breaches occur. When you reuse the same passwords across multiple websites, hackers thank you because they can easily access your email, banks, and other important accounts. This is why security experts recommend that you use a different, randomly generated password for every online account. With Bitwarden, you can create these randomly generated passwords that are different for every site you visit. And the best part is Bitwarden will manage all of this for you so you don't have to. Bitwarden works across your devices from mobile, desktop, browser plugins, and even on the command line. When you make the smart move and go check out bitwarden.com/DLN and get started for free. If you're like me, though, you'll want to access all that Bitwarden has to offer with the premium edition, especially since the premium edition starts at only $10 per year. That's right, $10 per year. Go to bitwarden.com/DLN and thank you, Bitwarden, for sponsoring the Sudo Show and the entire Destination Linux Network.
I feel like a lot of us in the IT industry came to work in technology from the influence of science fiction. For me, it was Star Trek: The Next Generation. A lot of us dreamt of working in space. Our guest today may not be Captain Picard, but the work he and his company are doing is in orbit over our heads right as we speak. Today, we bring on Tyler Browder, founder and CEO of Kubos, a longtime technologist, and a man who is taking open source from the cloud to space. Without further ado, welcome to the show, Tyler.
Wow, thanks for having me. Appreciate it very much.
Yeah, so Tyler, I gotta ask, obviously you have a big interest in space to start a company like this. What got you interested in space?
I'm interested in learning about things I don't know about. That's what got me interested. So my background is actually in entrepreneurship and business and building companies. And before that, my background was in music. And so I believe in being creative. Like my father always told me, follow your passions. And I always thought that was music, but it turns out what it is creation, right? It's building something from scratch. And so that's what led me down into entrepreneurship, building businesses, building technologies, building companies from nothing. And my intro into space goes back to a friend of mine named Marshall Culpepper. He is a software engineer. He was my partner who started Kubos. He came from the space industry. He wanted to build a business around this and asked me to help him build a business with him. So that's where kind of my genesis that started over lunch eating tacos in Texas.
There's nothing better than talking technology over tacos.
Yeah, right.
I'm sorry, the puns just keep coming out today. It's so how did you go from creating music to becoming interested in creation and space into technology? What was the kind of the final push?
I was really interested in like finding things at scale, right? Being able to take something in compound scale, and software was kind of an interesting, in space software became this way for us to really create scale more than other businesses that I've been familiar with that were much more human centric, right? And so that's really, I think, was really attractive to me was the scale that we could achieve with software, and then put that into space where scale is a whole different concept for us, right? And so I like the way that line tracked.
Tell us about Kubos, the company that you founded.
Yeah, Kubos is a software company for the space industry. So space is a traditionally and majoritarily hardware-centric world. People get into space to put physical things into orbit, right? And we really came at it from a software perspective, trying to bring software to the appropriate place it has in the rest of the world, right? Software eating the world in a lot of contexts, but space was lagging behind. So Kubos, that's kind of where we started. How do we bring software to the forefront, to an equal position with hardware in the space environment? And so we've done that a lot of different ways, tried a lot of different things. We've done open source. We've done onboard flight software. We've done currently right now, we're really focused on cloud technologies, bringing mission control, satellite operations. So that's what we build. We have a product called Major Tom, which is a cloud-based mission control software for satellite operations.
I love that product name, by the way.
Yeah, you're seeing the weaving of the music and all the things, right? There's some line to it.
Oh yeah, I didn't even connect those two things. Yeah, that's awesome.
Yeah. I would take credit. I can't take credit, though. I did not come up with the name. I wish I could, but it does resonate really well. In the early days when we were coming up with the product name, there was a strong just interest in music within everybody involved for whatever reason. So it really resonated across the entire team.
In terms of like this industry, I mean, this industry is, a bunch of big names like Northrop Grumman. My dad has worked for the company they acquired, Orbital ATK, for almost 40 years. One of ATK's acquisitions, Hercules, before that. So what are you trying to solve for them specifically? Like, is it just like tracking the satellites in orbit? What's the problem that you're trying to solve?
Yeah, sure. Well, first, what does Major Tom do? Major Tom tracks satellites. It allows you to understand the health and status of your spacecraft, and it sends commands or instructions to the spacecraft to do whatever it is you want it to do, right? So it's about situational awareness and it's about actionability, right? That's what we're giving our customers, our operators, information about their spacecraft. So this function, though, has been around since we've flown anything in space, right? So this is not a new, innovative thing that we're doing at the core, but it's something that's incredibly foundational to anything we want to do in space, regardless of what it is happening. So what we're doing differently is traditionally this software was highly tailored and customized to whatever the spacecraft was. And back then that was okay because we're going to build one really big spacecraft, really expensive. I want a really custom thing to do all the weird things that I want to do with it. And it's going to have to last for 15, 20 years. And that was great. It's going to live in a server, and I got a big budget, or ATK or Northrop Grumman's got a big DoD budget. They can afford server infrastructure, the IT staff to run these things for the next 15 years, collecting data and doing all the backup stuff and doing these functionality. When you go to do the next software or the next mission, it does not translate if you want to do something very differently. And so there is no economy of scale here, right? Going back to like scale, there's nothing to allow us. We have to basically start from scratch and redesign the system for this new spacecraft. Everything was spacecraft focused. So what we're doing is what has happened over the last 20 years is we're no longer building really big spacecraft. They're still being built, but the growth of the industry is in really small spacecraft, right? Moore's law is letting us get smaller. It's getting cheaper. SpaceX is lowering the cost of launch. And so they're throwing up large quantities of spacecraft. And so the bespoke, special, heavy infrastructure that costs more than the satellite itself is no longer going to work for our missions, right? It's about quantity, not quality of a single spacecraft, right? So we need a new solution for these new missions. That's what we're trying to do. We're moving it to the cloud, allowing us to rapidly integrate using APIs to allow us to integrate into a 15-year-old spacecraft that's been up there and into brand new satellite missions that are going to build hundreds of spacecraft. That is the unique position that we're bringing.
It sounds like a lot of like what the telco industry has done, from 4G to 5G, instead of going to your traditional network equipment providers like an Ericsson or a Nokia and buying these purpose-built appliances. And that's all that runs for the next 20 years, and telco industry even longer. Move that to software, make it's less bespoke.
That's right. So as we bring on new customers, new missions, we're not doing any customization to those things. Our customers can configure and integrate it into their system and therefore be more tailored to their system. But I don't have to build out new systems, right? So then I can bring on customers and scale without having to completely build a whole new team and dedicate teams to it.
True horizontal platform. I like it. And I always feel like that's been the end goal. Because I always feel like something that's been missing in, my customer base is telecommunications and people that may be dealing with satellites. And that was like the last thing that they could. It was like, yeah, we have this giant stack and we have 15 different stacks for each satellite we have in orbit.
Yeah. I mean, think of it this way. What the industry really is doing, if I can use this analogy, is moving from spacecraft being pets to spacecraft being cattle, right? We're moving to
We deal with that in the infrastructure space quite a bit.
Exactly. This is all it is, right? What we really want to do is blend away the difference between space and ground. You have a node in the desert, you have a node in space, you have a node wherever. It's just nodes, right? We're not quite to that vision, but that's what we're building, right? Is Major Tom. At the end of the day, Major Tom can connect to any system, right? External system. We focus on spacecraft. That's what we have a lot of tooling for, but it could easily, connect to your cell phone, right? Or it can connect to an IoT device. It can connect to your whatever you want it to connect to. And we have visibility across the thing. So just like the world is moving, right? We're moving away from these individual caring about the single to caring about the network, right? And we're caring about the system as a whole. And if one node goes down, it doesn't take my entire network, right? We want a resilient, redundant network. And that's really what we are. We're just a network administrators in a lot of ways. We're just focused on spacecraft.
Like we've implied, things like cloud native, 5G, edge, all of those things are moving away from this appliance-based pet technology system to something that you don't care if node 347 goes down because you've got 14 others that are built in to pick up the slack and provide redundancy until you can replace that particular piece of hardware. It just so happens that your hardware is up in space. So I say that to lead into my next question of what types of workloads are you working with? Is it GPS? Is it communications? Who are some of the, if you can't use specific names, then what are some of the workloads, some of the industries you're working the most with?
Yeah, so we consider Major Tom to be size agnostic, so spacecraft size agnostic, and payload agnostic, right? And so we focus on the actual vehicle of the spacecraft. All vehicles have similar functions, right? You need solar panels, you need a battery, you need a radio, a computer, and you need some way to turn it, right, to point. Now, what the payload does, it doesn't matter if it's an imaging, an IoT communication, telecoms, scientific, weather, does ship tracking, it doesn't matter. It needs all those core functionalities, right? And so we focus on that, which allows us to get into lots of wild things. So we have customers that do imaging. We have customers that do scientific missions, collecting research out of the atmosphere. We do weather. We do IoT communications, spinning small packages of information instead of large quantity. And we're moving further and further away from Earth too, right? So that's the other thing we have the advantage of. We don't have to be in low Earth orbit. We can move into MEO. We can move into GEO. We can go over, further and further into Moon and on. That's something that's different from us. Software allows us to scale that way. If you have a thruster, it's not going to scale the same way on a 10 kilogram satellite as it will on a 1,000 kilogram satellite. The physics doesn't work. I can do it though. To answer your question, sorry to go off on rants.
No, that was great.
We get ourselves into everything. We do not focus or specialize in any type of application that our customers or information that our customers are collecting.
So your focus is more on, to use a term that a lot of our systems administrators and whatnot would be familiar with, you're more focused on the infrastructure, almost on the operating system management piece, so much more operations focused than what that application is. Because for a lot of us that spent years in IT operations, spent a lot of years in data centers running cable, it didn't matter what the payload was, whether that was a database or a front-end web server. It didn't really matter as long as the hardware and the operating system were doing what they needed to do. You're just providing a way to manage those at scale.
100%. There's a lot of similarities to data centers as there are to spacecraft, at least in the world we're moving to, where the industry is moving to. And yeah, we aren't concerned with particular what is, right, what they're doing, which I think is an advantage. A lot of companies, they build this radio and it builds on this frequency. Well, then it needs this much battery power, which means it needs to be this big because it has solar panels, which means you have already limited who your customers can be, right? I don't have that problem. Anything in space can be used by Major Tom, can be operated by Major Tom.
You say anything could be managed by it. Is that possible? Like, is it through like some plugins that the customer would write to integrate into the platform? Like, how is that accomplished?
Sure. So in space, there's two absolutely have to have integration points with any spacecraft and ground system, right? Regardless, you use our system or somebody else's system. You have to integrate with the spacecraft, right? So you have to speak the same protocols and same communications. And you have to have a communication link, right? In our most examples in space, it's modem turning it into RF signals, sending it up to spacecraft collects it, turn it into digital. So you have to have that connection, right? And you have to integrate into this ground station, grid antenna, wherever it is, and be able to communicate, send data to it, get data from it, control it, point it, all those things. So those are really the two critical points of integration that everybody's always had to do. So what we've done is there are networks out there of ground stations you can rent time off of. So it's a service. So we've gone out and pre-integrated those. So we removed that integration point for our customers. So then we're down to the spacecraft. So what we've done is created a WebSocket, and we ask our customers to create a translation layer between the spacecraft protocol that they're using on board and the protocols that we use in Major Tom through the WebSocket. And so that's how our customers integrate with it. Other systems support certain protocols, and you have to make sure you're lining up the same implementation of those protocols. We decided to go a different direction, allow customers to right integration layers between the spacecraft, which also allows them the right integrations layers between any other system, right? Databases or applications that they wrote custom. Those are the two critical integration points that everybody has to do. We've taken care of one through our partnership network and our ecosystem we built. The other one that customers have to implement themselves.
Makes sense. Is there a good starting point for those customers to use? Like, obviously, probably REST APIs, or do you have like pre-built like Ruby or Python SDKs?
So there's a couple ways we do this. So we have Python examples of these gateways. We also have a tutorial built into the product to walk you through building these things. So we use two different APIs. One's the WebSocket with a JSON format, and then the other one is a GraphQL API. So those are the two that we're using currently. There's been some discussion on where to take those and iterate on those. But for right now, that's what we're doing. And yeah, so we have documentation that walks customers through it. We have example code on how to write these gateways, what we call gateways, these translation layers. And yeah, obviously then we sell support packages with this.
The inner nerd in me cannot just get past the fact that you are writing automation and API-based management for satellites. I mean, that's really cool. That's not something you hear about every day. I mean, to most people in kind of the end user community, it's still this fascinating thing that's distant. We're talking about elements of cloud native and automation and management that we talk about. You're presenting these topics that we talk about, and for Brandon it's telco, for me it's infrastructure operations, and you're talking about sending packets into space like it's just another day in the office for you. But it hasn't been that simple the entire time. In fact, we were kind of talking a little bit about that timeline in the pre-show about how you've expanded. You started out with basically your own Linux distribution and then tried out a couple of different projects around hardware and whatnot. You want to kind of talk about the process a little bit of some of the different approaches you took to this before you landed on kind of a cloud native type approach to satellite management?
So Kubos originally started with the idea of building an open source Linux distribution for spacecraft flight software, right? So it actually goes on the satellite, is launched with the satellite. It's the OS of the satellite, and it's the operations of the satellite. Just like Major Tom focuses on the infrastructure play and not so much the payload, that's exactly what the Linux distribution as well did. It focused on the bus operation, make sure we're grabbing all the telemetry from all the batteries, all the computers, the radios, and being able to send them commands, right? And then store all the data and then downlink it from into the radio. So that's where we started. It's still a project that's out there. Kubos, you find it on GitHub. People are still flying it. Problem with that product is not the technology. It was the business model. The business model was the problem. And so that's why we shifted. We looked for new ways to monetize in this industry. We were able, through our connections, to offer, customers that had taken Kubos, the flight software, we were able to, they needed also ground operations software, right? So then we were able to sell the Major Tom product. But so that was Linux. It was a Linux distribution, open source, and we'll have middleware on top of it that allowed APIs so you could customize new applications on top of it so you can build what you want. It's very similar to an Android operating system, the way we architected it, and also that it was hardware agnostic, so you could easily swap it around to different satellite vendors and manufacturers. It's still a cool piece of technology. It's just, it wasn't a technology problem. It was a business model problem.
Yeah, monetizing Linux is hard. I mean, as far as I can count really two companies that have truly monetized it. So, and Red Hat and SUSE. And it's really hard to replicate those models. But, aside from it, kind of looking like Android light, I was reading the documentation. It was using a real-time kernel. Was there like an advance? For me, it's obvious, but I'll let you answer. Why'd you pick a real-time kernel? Like, why didn't you just use the standard Linux kernel?
Right. That's the worst thing about space. If the hardware fails, that's it. Forget about it. You'll never figure it out, and it's over, and it's gone. Frustrating. Or the rocket blows up. There's lots of frustrating things that are choke points in this whole thing. The dominant OS in space for the longest time was an RTOS, right? It's a real-time operating system, bare metal. They did not want anything complicated. They were single focused, do it XYZ, do it in that order, and don't do anything else. There was a shift in the market towards now that we were able to have more beefy processors at the same size, right, form factor, that were more power efficient, we could run Linux on it. That gave us a lot more flexibility around the portability of things and around the way we could write more. Also, the idea was we could bring in more software talent. So most of the software written in space historically has been written by electrical engineers writing software, right? And we wanted to bring in more software developers into the market, give them a tool they could wrap their hands around, right? And not have to, they could use the skills they've been using and use it in space environments. So, but there were still some needs for real-time applications on board the spacecraft, right? Particularly around attitude control. If you can imagine, there's different ways to point a spacecraft, and those need quick, zero latency type real-time functionality right there, especially when you were dealing with a thruster. All right, so you want it to point and thrust and be able to turn and all these different things. So we also had customers' demand for keeping as real-time as possible. So that's why we implemented a real-time kernel, because we were trying to have the best of both worlds. It was challenging. It wasn't as simple as we would like it to have been, but we were able to, do that successfully.
One last question for me on it. I got excited when I saw Rust bindings. So what was your want or need to go to Rust? Was it just because of speed? What was the...
It was really more about kind of the safety of it, right? It was a replacement for C, and we wanted that it would become a safer, more critical software, right? So Rust was not used in space. We were the first ones to do it. It's taken a little bit of hold in space, but we needed something that would have more safety protocol, more safety checks in it before pushing this code. Especially if you think about it, if we're on orbit and we make a mistake and we're uploading a C code and something got through and it bricks our spacecraft, right? And then that's the end of it. That the whole thing's gone. We needed better. We couldn't just rely on our customers having better, testing, right? CI, but we needed also to enforce on our own. So that was our decision to go to Rust. That had pros and cons. Pros, and we accomplished what we wanted to do. Con, there's a learning curve, and particularly for our types of customers who were electrical engineers, that was a steep learning curve at time. But man, when you found the one who knew about Rust and they got real excited about using it. Every once in a while you come across somebody who's a nerd and that's like, that's what I want to use, and you did it, so let's do it. And they got really excited about it, and that was fun.
Yeah, when earlier this year, Linus Torvalds says I'll accept Linux modules written in Rust now, I got super excited myself. Yeah. So I'm like, maybe I'll start contributing to the kernel again.
Right. It's good. I mean, I feel like we did a lot of first. We weren't the first open source project in space. NASA has something, but we were one of the first to put Rust in space. We were the first cloud offering as a commercial service for ground systems. I've been really proud about some of the legacy that we've created. Even though Kubos, the flight software, is not our primary focus at this point, it's still there. I mean, people still use it. It's still picked up. There's a community around it, and that's something we're quite proud of as well.
And you're doing some fantastic things. I mean, as we scale out our, as a civilization, scale out our space infrastructure. I mean, just thinking about Starlink, all these lower satellites just that need to be managed and monitored so we know where the hell they are. That's going to be as soon as they start saying that, I'm like, that's a lot of stuff to track. I hope they're tracking it properly, thoroughly.
Yeah. One of the problems I'm really excited about tackling that we're in a good position to really take on is that problem, right? So say you have 1,000 spacecraft in orbit. They're still really small. Space is big, right? So they're easy to lose. Okay, now you say you have 20 ground stations that are static on the Earth, right? So everything's moving and shifting. And these satellites, they're orbiting the Earth every 90 minutes, which means with a ground station, they get about 10 minutes of connectivity per every 90 minutes, 10 minutes connectivity. So you strategically place the ground stations, right? So you're getting more every pass. or every 90 minutes, once in orbit, you're getting more touches. The problem is this satellite right now is passing over New York. In 90 minutes, it's going to be 50 miles east of New York. And in 90 minutes after that, it's going to be 100 miles east of New York, right? It walks and it doesn't stay. So now you got everything shifting. And so the problem that I'm really interested in solving, like going back to this networking problem, is optimization. If I want the network, to take a picture of Cairo tomorrow at 2 p.m., what ground station, satellite do I go through to tell the satellite that's going to be in position at 2 p.m.? How do I know which one it is? And then how do I tell the satellite to downlink that image so that I can get fast as possible back to my customer, right? This is this interesting optimization problem. And then you throw in weather, right? So, these are optical images. You can't take, if it's night, we got to wait or if it's cloudy, you got to wait. These are really interesting optimization. That's really where we have to go to in order to really build these constellations. And that's what we're going to tackle.
That's awesome. What I'm also excited about, I haven't started yet, but it's in my backlog, is Kubos actually has a podcast as well. So why don't you tell us a little bit about that?
Yeah, we kicked off a podcast recently trying to highlight, more about what we do as individuals, where we came from, but also interview people in the industry who are advocating for use of the cloud. That's kind of this mission for us. Cloud has been this scary thing in our industry, and with Microsoft and AWS are dumping lots of money into educating the industry on the cloud, but also providing services, obviously, in the cloud, and about interviewing and learning about this movement that is happening. And so the podcast is called Ground Control Checking In. Find it on our website, kubos.com.
I know that you don't have a ton of open source projects. I mean, there's still a little bit of activity with Kubos, but other projects that people could get involved in that you have, like whether that's just like showing examples, is I'm always thinking about on the open source side, like how can we help?
Sure. Kubos is definitely something to do. It's a small, but it's a passionate community of users for Kubos to keep contributing to it, to keep it growing, to keep it moving. And so that would be where I'd really start. There's a Slack community, but there's also a Discord community out there. There's lots of, I've lost track of these independent projects that are springing up out of it. But if you're interested in like open source and space in general, NASA has an open source flight software as well. They also have an open source ground system, which you don't want to go to that one. But anyway, the flight software is fun. NASA has one. No, there's an open source mission control software called that from Ball Aerospace as well. There's other open source, the Libre Foundation. They put up a whole like open source spacecraft. They have a open source ground station hardware and software that you can build and listen to spacecraft with out of put in your backyard. There's all sorts of open source projects happening. That's called SatNods, that does the open source ground station network. Check it out. It's cool. There's open source spacecraft hardware schematics. And so space is limited by export control, right? We get pigeonholed a lot under ITAR and so sharing outside the United States with other countries can be challenging unless you open source it. If you open source it, you get to go under the academic, free for all, accessible to all, and you get around a lot of it. That's one reason why we made it open source to begin with, is we didn't want to deal with the headache of export control. Anyway, there's lots of ways people can get involved with open source in space. We're big advocates of it, even though it is not a huge part of what we're doing right in this moment, but it's still something we're very passionate about.
So last question. It's cheesy, I know, but we got to ask. There's more satellites going up every day. You can watch it live on YouTube. Just about any time there seems to be something going up. And there, like you said, there's more and more funding being put into this, even from just a communications perspective, transportation, all of these things. What does that say for Kubos? And so what's kind of the next big thing or the next milestone for y'all?
Another thing I'm really interested that we're driving for is we're really good at understanding what happened with your spacecraft and what your spacecraft's doing today. What I want to do is move into being able to predict what your spacecraft is going to do. Not just where it is, but how it's going to perform. So if we're collecting telemetry across lots of different customers, different satellites, different size, we start to have a data set that we can actually do some predictive algorithms on top of, saying this battery is showing signs that it's going to fail in the next 6 months, right? Being able to provide analytics and analysis, predictive analysis, is kind of the next thing that we really want to push. That goes into the optimization piece that I described earlier. These are the two big buckets that we're really moving into over the next 12 months.
So you're taking cloud native, open source, all these other things, and now you're throwing out AI ML. So you guys are doing pretty much what
I didn't say that. Now, see, I didn't say that. Now, you said I didn't say it. I never said those particular things. That's right.
I'm in marketing now. I gotta make sure we hit all the buzzwords.
That's right. I wouldn't be doing my job if I didn't hit a buzzword, but I didn't say it, right. So it's okay.
Fair enough. I will take the blame for that. Well, any closing thoughts or anything, Tyler, before we wrap it up?
No, I really appreciate the opportunity, guys, and to talk to you about what we're doing, but also get to know y'all. So thank y'all very much. Appreciate it.
Definitely. It was a long time coming, but really glad you came on the show and talked space a little bit. It's been a love of mine since I was a little kid. So it was great to talk about technology and space.
Yeah, I really appreciate it. Thank y'all.
You can catch Tyler, Kubos, and Major Tom and a link to their podcast all in the show notes. If you accidentally unleash Skynet on the world, or if you manage to contact any alien races, remember the Sudo show, come back and chat with us first, if you don't mind.
Obviously that's what I'll do.
Thank you so much for joining us today. As always, your feedback is welcome. Head on over to sudo.show/discuss. If you'd like more of Brandon and I, you can find it over at sudo.show and on social media at Sudo Show Podcast. You can catch more awesome content over at our network partners, destinationlinux.network. Brandon, anywhere else you'd like to send folks?
You can follow me on Twitter at dbrandonjohnson or my website at open-tech.net.
And you can head over to Red Hat TV to catch me live every other Wednesday on Red Hat Enterprise Linux Presents. And, of course, you can follow me at ITGuyEric on itguyeric.com. Remember, the Sudo Show is your place for all things enterprise open source. Until next time.